everyone. I welcome you all to this lecture. In this session, we are going to learn complete test procedure of hydrometer analysis of soil. This test is performed as per the Indian standard IS 2720 part 4. The main aim of this test is to determine the grain size distribution of a given soil sample. By performing this test, we will able to find out what percentage of the soil particles are of what sizes, especially the finer particles like silt and clay, which cannot be separated by sieving. The engineering behavior of any soil is greatly influenced by the size of its particle and how these particles are distributed, whether it is well graded, whether it is poorly graded. So we can find this gradation by this curve or by conducting this test. That is why grain size analysis is one of the most basic and important tests in soil mechanics. It helps the engineers to classify the soil and predicts its engineering behavior. For coarse grain soil, sieve test is done, and for fine grain soil, hydrometer test is conducted for determining the grain size analysis. A soil is called coarse grained if more than 50% of its particles are larger than 75 micron, and it is called fine grained if more than 50% of its particles are finer than 75 micron sieve. Fine grained analysis is carried out by the hydrometer method, which works on the principle of sedimentation analysis. And this analysis is based on the Stokes law. According to Stokes law, the velocity of free fall of a spherical fine particle through a liquid is different for different sizes. Larger particles settle faster and smaller particles settle more slowly. In the case of soil, even though the actual grains have different shapes, we assume that they are spherical and that all particles have the same specific gravity. So in hydrometer analysis, first a dispersed soil water suspension is prepared and allowed to settle in a sedimentation jar as it is shown in the figure. According to Stokes' law, larger particles settle faster while the smaller particles remain suspended for a longer time. It means the bigger particles will settle first and the smaller particle will take some time. At any selected time, we insert the hydrometer into the soil suspension, and the hydrometer measures the density of the suspension at an effective depth. And from that density, we can calculate the particle size and percentage finer. So let's understand the Stokes law, which is the foundation of this hydrometer test. So a Stokes law is a principle in fluid mechanics that describes the motion of a small, smooth, spherical particle falling through a fluid under laminar flow condition. It gives the terminal velocity of the particle based on the balance of forces acting on it, namely gravitational force, buoyant force, and viscous drag force. And the velocity v can be found by this formula gs minus 1 g d square divided by 18 mu, where gs is the specific gravity of soil solid, small g is the acceleration due to gravity, capital D is the equivalent particle diameter which we are finding, and mu is the dynamic viscosity of water. Although Stokes' law is the basic principle of this hydrometer test, it has some important limitation that we must keep in our mind. First, the analysis assumes that the falling grain is perfectly spherical. In reality, the finer particles of soil are never truly spherical. They have irregular shapes. The second limitation is Stokes' law considers the velocity of free fall of a single sphere in a suspension of infinite extent. But in the laboratory, we perform the test in a glass cylinder where the extent of the liquid is limited. So it is not infinite extent. The walls of the jar affect the settling of particles. Third assumption is, or the third limitation is, we use an average value of a specific gravity for all the soil grains. However, the actual specific gravity of some individual grains may be different from the average value. And fourth, the finer grains of the soil carry electrical charges on their surfaces and therefore have a strong tendency for flocculation. That is, they stick together and form flocks. This is why we always add a dispersing agent to prevent flocculation. So here is the complete list of equipment which we need during the test. Hydrometer is the main apparatus which we will use in this test. Then glass measuring cylinder of 1000 ml capacity. Two numbers of this glass measuring cylinders. Thermometer, stirring apparatus, 75 macro sieve, electronic balance, stopwatch, and evaporating dish, wash bottle, and deflocculating agent, sodium hexametaphosphate or sodium oxalate. Before starting the actual test, for calculation, we need some data. So first we will find or we will understand those data, then we will perform the test. So firstly, we need to calibrate the hydrometer. For this, we need the volume of hydrometer. So for determining the volume of hydrometer, take the water in this 1000 ml measuring cylinder up to 800 ml. Now insert the hydrometer. Then water will go up, or the this mark will be higher. So note down that reading. So here initial reading is 800 and after immersion the reading is 870 ml. So the difference of this reading will give the volume of hydrometer, which is here 870 minus 800, which is 70 ml. Now we need to find the cross sectional area of the cylinder. For that, just take any two reading. Here we assume or we have taken 400 and 500. So difference is 100 ml. Now the measure the distance between them in centimeters. So distance between them is 3.3 centimeter. So cross sectional area of the cylinder will be this volume by distance, which is 100 by 3.3, which is here 30 centimeter square. So volume of hydrometer we got 70 ml and cross sectional area of the cylinder, measuring cylinder, is 30 centimeter square. Now, uh, when we take the hydrometer reading, this reading has some error. So we will understand those error and why those error occurs. So accordingly, we need to apply some corrections. So first correction which we will study is meniscus correction. So here, when we insert the hydrometer, we will take the reading, or the water will goes some or at a height in the hydrometer due to some surface tension. So we will take the upper reading of the meniscus, but actual reading is just below that reading. So first we will find this error. So whatever error will be there, we will apply the correction. So for that, first fill a 1000 ml measuring cylinder with water up to 700 ml graduation. Next, insert a clean hydrometer. Then read the top of the meniscus where the water will appears. Now, just take the reading of this horizontal water level, and the difference between them will be the meniscus correction. So here in this experiment, we found the meniscus correction is 1, and it is always positive and is constant for the hydrometer, for a particular hydrometer. Next correction is dispersing agent correction. So for removing that flocculation tendency, we need to put some dispersing agent. Here we have used sodium hexametaphosphate and sodium carbonate. So due to that chemical, the specific gravity of the soil suspension becomes higher. So that will give again uh, some error while taking the reading. So we will apply the corresponding correction. So how to find that corresponding correction? So first prepare the solution of this dispersing agent. So for that, take 33 gram of sodium hexametaphosphate and 7 gram of sodium carbonate. Here it is just 33 gram of sodium hexametaphosphate and 7 gram of this sodium carbonate, and mix it in a beaker. with help of mechanical stirrer. So once it is thoroughly mixed, just put it in a jar. Put it in a jar and make the volume by applying water, extra water up to 1000 ml. So this solution is prepared. So now we will understand the correction. So take 50 ml of prepared solution in an evaporating dish. Take a evaporating dish and take 50 ml of that solution and weight that solution. Suppose this is W1. Now just take this or keep this solution in an oven for 24 hours. The temperature will be 105 degrees Celsius. Now after 24 hours, take the weight of that evaporating dish. This will be W2. So difference between this W2 and W1 will be the mass of dispersing agent. And the dispersing agent correction will be twice of this mass of the dispersing agent, 2 into WT. And this dispersing agent correction is always negative and is independent of the temperature. So while taking the observation, after taking the observation, in the calculation, we will apply this dispersing agent correction. Alternatively, we can also find this dispersing agent correction by simple method. Just in a 1000 ml measuring cylinder, which contains this dispersing agent, the hydrometer is immersed in that prepared solution. So this will give some reading. Now the same hydrometer will be inserted in a measuring cylinder containing only water up to 1000 ml mark. Then that will again give some reading. So the difference in both the reading will be the dispersing agent correction. Now the third correction is temperature correction. This correction is done because each hydrometer is calibrated at a particular temperature, generally at 20 degrees Celsius. But while doing the experiment, the temperature may not be same as 20 degrees Celsius. So, with fluctuating temperature, we need to do correction. So, if the test temperature is above the calibration temperature, then the correction is added. And if the temperature is below the calibration temperature, it is subtracted. So, temperature correction chart is usually supplied by the manufacturer of the hydrometer, or we can calibrate, or we can find in the laboratory itself. So, this we understood how to prepare the dispersing agent solution. The next step is to prepare the soil sample. So first take 50 gram of soil which is passing from 75 micron sieve. Now add 100 ml dispersing solution to this soil and then add some water, approximately 25 ml of water. Then thoroughly mix it and make a slurry. Just just boil it or not boil it, just warm it for 10 minutes at 80 degrees Celsius. Then again, just mix it with the help of mechanical stirrer. Now, once this slurry is prepared, just convert this slurry into a this measuring cylinder, and again pour some extra water up to 1000 ml cylinder, and thoroughly mix it. And just while mixing, consider all the soil particles in motion. No particles should be settled down in the bottom. So it is mixed end over end inversion, up and down. Now start the reading, conducting the test. So just after placing it on a horizontal table, hydrometer, insert the hydrometer and start taking reading at 0 second, 15 second, 30 second, 45 second, 1 minute, 2 minute, and 4 minute. Then just remove this hydrometer and keep in a plain cylinder containing water only. Then again take reading at 88 minutes, 15 minutes, 30 minutes, 1 hour, 2 hour, 4 hour, 8 hour, and 24 hours. And again, after each reading, remove the hydrometer and keep in a plain cylinder which is containing water only. And also take the temperature corresponding to each readings. So this is the observation table. So here in the first column, just note down the time, 0 0.5, 1 minute, 2 minutes, and the unit of this time is will be minutes. Then temperature will be noted down. The viscosity of water mu corresponding to that temperature. Then take the hydrometer reading. Hydrometer reading. Suppose here 40, 36. There will be some mark in the hydrometer, as we can see here. Just see here. There are some marks. 5, 10, 15, 14. So whatever will be the marks, see the upper part of this meniscus. Uh, so here, note it down, RH. Now, H1. H1 is the length from neck of the bulb to the graduation RH. Suppose here we found this, suppose we found 20 mark RH. So find the length between this H to 20. Here from the neck to 20, it is 8 centimeter. So note down 8 centimeter. Suppose we got 40 as RH. So find the distance between from neck to 14. Here something 4 point something, 4.4, 4.5 something. So note down this H1 4.1 corresponding to RH40. So for each hydrometer reading, just take the length from the neck of bulb to the graduation RH in centimeter only. Now find the effective depth HR. So HR will be found by this formula. This formula HR. HR is equal to H1 plus half H minus VH by A. H1 just we have calculated. H1 is the length from neck of the bulb to the graduation RH in centimeter. A small h is the length of the bulb here, just length of the bulb from neck of the bulb to the bottom part of the bulb. Here it is 15 centimeter length of the bulb or height of the bulb. A small h. Capital VH is the volume of hydrometer which we have calculated earlier, and A is the cross sectional area of the jar. So here volume of the hydrometer came 70 as we have calculated earlier in the previous slide, and area of the cylinder is 30. So by applying those formula, we can calculate this HR effective depth. Then temperature correction. Here temperature correction is 0 because the lab temperature was 20 degree only. Now corrected hydrometer reading. This reading 40, 36, 32 RH was having some error. So we will apply here meniscus correction, temperature correction, and dispersing agent correction. So meniscus correction we found here for this lab or experiment was 1. So this will be added RH plus 1, and dispersing agent correction we found 0.5. So this will be subtract 0.5, and CT is 0. So applying those correction we will find corrected hydrometer reading is in this column 40.5, 36.5 corresponding to each hydrometer reading. Now diameter D can be calculated by this formula 30 into mu by 980 G minus GW by HR by T. Mu is the this viscosity of water. G is the specificity of soil solid which we have taken. GW is the specificity of water. HR is the effective depth. T is the time in minutes. So applying all these values in this formula, we will get diameter D. Now percentage final W. W will be 100 G by WS into G minus 1 into RHC, that is corrected hydrometer reading. So G again a specificity of soil solid. W is the weight of the soil which we have taken for the this test. So we have taken WS as 50 gram. We have taken 50 gram initially soil. So WS will be 50 gram. G again a specificity of soil minus 1 into RHC. This is this value. This corrected hydrometer reading. So again putting all this value in this formula, we will get the percentage finer. Now this percentage finer will be converted into combined percentage finer. Combined percentage finer means the soil which we have taken was passed through 75 micron. So previous before conducting this test, we have to perform the sieve analysis, from where we will get this percentage fine grained soil from sieve analysis. Percentage fine grained soil means the percentage finer from 75 micron sieve. How much that soil have passed through 75 micron sieve. So here from sieve analysis, we got that 50% soil passed from 75 micron sieve, that is 0.5. So just multiply this factor with this percentage finer, we will finally get the combined percent finer. So this we will draw the graph of this percentage finer in y-axis and diameter d is in x-axis in a log scale. So we will find the grain size distribution curve. So I hope you have understood this test. For any confusion, we can just put your question query in the comment section, or you can approach to me through mail. Then the problem will be discussed. So I hope you have understood this hydrometer test. Uh, Thank you.